Welcome back to the Green Mac TV channel. Inside the Agio plant of UD Trucks, Japan's legendary craftsmanship meets robotic precision. Every Quon truck begins its journey as a flat sheet of high-strength steel, entering the stamping line, where robotic arms place the metal onto 1,000-ton presses. Each press molds the panels into their distinctive curves, fenders, doors, and cabin frames, all formed under immense force and micron-level precision. Before moving forward, every stamped panel undergoes visual and tactile inspection. Workers verify that no unevenness exceeds 8 micrometers, while sampling inspections ensure defect-free quality. These panels then travel to the welding line, where sparks of automation fuse them into a rigid cab structure. UD Trucks employs a fishbone welding layout. Sublines branch from the main line, maximizing efficiency. Here, dozens of robotic spot welders operate in perfect synchronization, melting metal together with electric current and pressure. The plant uses a jigless robotic welding system, allowing the machines to swap welding guns and copper electrodes automatically. Precision, repetition, and balance define every motion. Next, the newly assembled cabs are transferred to the paint line. Before painting, each unit passes through chemical pre-treatment and undercoating baths, removing impurities and creating a perfect base layer. Using an electro-deposition process, the cab is dipped in a paint pool while a controlled electric current ensures uniform coating across every surface, even deep recesses. Afterward, the cabs are baked in ovens at 170 degrees Celsius, locking in corrosion resistance. Robots and skilled painters then apply the final color coats with pinpoint accuracy. Each top coat is cured again at 140 degrees Celsius, ensuring durability and shine. UD Trucks offers custom paint options with up to 4 color combinations from more than 600 shades. Precision masking allows even the most complex designs to be replicated perfectly. The painted cabs then move to the trim line, where interior modules such as dashboards, meters, switches, and storage units are pre-assembled into modules and installed efficiently. Automatic guided vehicles, or AGVs, deliver these modules directly to workers. Heavy components like windshields are positioned with robotic lifters to reduce strain. In the Agio plant, automation and human craftsmanship coexist in harmony. Robots ensure precision. Engineers safeguard perfection. Each UD truck leaving the line carries decades of experience, technological mastery, and the quiet pride of Japanese manufacturing excellence. In parallel, the engine assembly line prepares the heart of the Quon. Pistons, crankshafts, and cylinder blocks are assembled with robotic precision. Each piston is inserted using a robotic arm equipped with a pressure sensor, adjusting position and depth in real time for perfect alignment. Every torque applied by an electric wrench is digitally recorded for quality tracking. Once engines, transmissions, and axles are pre-assembled, they are delivered to the vehicle assembly line, where the frame and cab finally unite. Using advanced lifting and alignment systems, workers can raise, rotate, or lower the massive components to maintain perfect posture and minimize fatigue. The plant operates two main assembly flows, the east-west line and north-south line, enabling simultaneous vehicle builds for maximum flexibility. On these lines, the magic carpet system moves floor platforms with the workers, maintaining ergonomic balance throughout the process. Every bolt is tightened with an electric torque wrench, its data instantly logged into the central system to guarantee traceable precision. The noise in this vast hall is remarkably low, under 70 decibels, reflecting the plant's advanced acoustic engineering and worker comfort design. After assembly, each truck enters the final line, where exterior fittings, lighting, and bodywork are installed. Here, workers perform fine adjustments while AGVs synchronize movement with the line. During headlamp inspection, a specialized optical axis tester calibrates each beam for optimal visibility. On the final inspection line, every function is tested, from ABS and differential lock to cruise control, speedometer calibration, and vibration analysis on rolling testers. Each truck undergoes a complete drive simulation to detect any irregular sound or imbalance. Every heavy-duty truck depends on one essential component, its steel wheels. What seems simple at first is the result of a complex and precise manufacturing process. The process begins with a thick, flat steel plate, carefully selected for consistency in composition and hardness. Using high-tonnage hydraulic presses, the plate is punched into perfectly round blanks, each one a future disc. These blanks are then heated to the ideal forming temperature, soft enough to shape, but strong enough to retain structure. Next, the blanks move into the deep drawing and stamping line. Here, enormous presses exert thousands of tons of pressure to stretch and mold the steel into its signature bowl-like shape. In a single, fluid motion, the once flat sheet becomes a three-dimensional form capable of supporting heavy structural loads. After forming, CNC punching machines create precise bolt holes, center bores, and ventilation slots. The positioning of these holes must be accurate within fractions of a millimeter. Any deviation could cause vibration or imbalance at high speed. Each hole is laser measured, ensuring a perfect geometric pattern that will match seamlessly with the truck's hub and brake components. It all begins with large coils or sheets of low-carbon alloy steel. After strict quality checks, the sheets are cut into blanks and fed into high-pressure forming machines. These blanks are then hot-rolled and shaped to achieve the initial curvature of a wheel rim, ensuring consistent thickness and grain alignment across the surface. Then the newly formed wheel then goes through heat treatment, improving the internal structure of the steel. This stage enhances its strength, elasticity, and impact resistance, critical for trucks that carry tons of cargo every day. Afterward, the wheel enters the machining section, where bolt holes, mounting surfaces, and hub centers are accurately processed using CNC machines. The balance of the wheel is tested, and any micro deviation is corrected to ensure stability even at high speeds. Next comes the forming and welding stage. The rim and disc, the two main parts of a wheel, are shaped separately and joined together using precision welding systems. Each weld is tested to handle extreme loads and fatigue cycles found in long-haul transport. Before leaving the factory, each wheel undergoes a series of inspections: dimensional measurement, X-ray testing, load simulation, and air tightness verification. Only those that meet the highest standards are approved for shipment. Once the geometry is confirmed, the surface treatment begins. The wheels are cleaned, degreased, and coated, first with anti-corrosion primer, then with durable powder coating or paint. These finishes not only enhance appearance, but also protect the wheel from salt, moisture, and years of wear on the road. From raw steel to shining finished product, every stage combines metallurgy, automation, and precision engineering. The result: steel wheels that can endure millions of revolutions, carrying heavy trucks safely and reliably across countless miles. In the heart of Vietnam's industrial growth stands THACO Industries, the nation's largest and most advanced trailer manufacturer. With a world-class production scale, a team of highly skilled engineers, and synchronized technology, THACO has become a trusted name not only at home, but across the USA, Australia, Mexico, and Canada. Each trailer is born inside a modern, closed-loop production system that integrates precision, automation, and research-driven innovation. With a capacity of more than 30,000 units per year, the plant operates continuously, powered by fiber laser cutting machines, CNC pressing systems, and over 40 automatic welding robots imported directly from Japan. Every weld is executed using Sigma 5 servo control, guaranteeing uniformity and strength across every frame and component. In the surface treatment section, the production enters a new dimension of quality. Semi-trailers are automatically cleaned inside giant shot blasting booths, creating ideal adhesion for coating. Then, each chassis is dipped through a full-length ED coating system, hardening the steel surface and providing up to 1,000 hours of salt spray resistance, a critical protection standard for export markets. The next stage features electrostatic powder coating lines capable of lifting up to 4 tons per load. Under controlled temperature, the coating bonds firmly to the steel, forming a glossy, scratch-resistant, and corrosion-proof finish. At the assembly stage, automated monorail systems streamline installation. Axles, suspensions, air tanks, lighting systems, and wiring harnesses are fitted with robotic precision, reducing labor demands while maintaining total consistency across production batches. Every tire starts with raw materials, and at Sailun, the journey begins with over 200 ingredients: rubber compounds, carbon black, steel, textiles, and advanced chemicals. Inside their flagship manufacturing facility, spacious as over 100 NFL football fields, massive mixers blend synthetic and natural rubber into a uniform compound. Next, the material is milled. Layers of steel and textile belts are added, and beads are formed to build the tire structure. The green tire is shaped, then cured under high pressure inside molds that imprint tread patterns and branding. After vulcanizing, the tire undergoes final inspection. Balancing, uniformity checks, and rigorous testing ensure it meets Sailun's global quality standards. From compound to finished product, every step in this factory is automated, high precision, and built for scale. Welcome to the future of tire manufacturing.